What are slides? They are a set of moving sections that are attached together so they can slide back and forth linearly. They are able to move back and forth due to the ball bearings that are placed in between each sliding section. They are powered by a motor which is connected to a string. Strings are held by pulleys on the slides for them to extend. Telescopic slides. They are sliders with moving sections that retract inside of each other. A three-step linear slide, which means there are three moving sections that are attached together. As the slider extends, the section's thickness decreases. Three-step sliders have a stroke that are bigger or equal to the length of its actual slides. Same type of slides as one to the right, but the difference is that this one only has two moving sections, and two-step sliders have a stroke of less than the actual length. These sliders are the ones used most common in FTC. Instead of moving sections that are stored inside of the first stage and on, this slider is stacked on top of each other. The pictures to the right are an example of the three-step slider, and they are easily smaller than the sliders in the previous page. Commonly used slides and attachments in FTC. The ball bearing slide packs in GoBuilder are four pieces of L-shaped brackets that has ball bearings attached to it, which can hook onto two channels and create a two-step slider. The Ultra Slide from Rev, which is basically a slider attached to a Rev extrusion. It works like a two-step slider. The 15mm linear motion kit from Rev are used with Rev 15mm extrusion to create compact linear slides. The V-wheel kit from Actobotics are four wheels that can be attached to plates, which then can be rolled on an Actobotics X-rail. The three-step sliders from Mizumi are made with steel or aluminum. Steel is strong but heavy. Aluminum may bend slightly, but is way lighter than steel. For the same size Mizumi slides, 20 by 16mm, the aluminum slide weighs 8.8 ounces, while the steel slide weighs 14.7 ounces. The 1.2mm cord from Rev are high-strength strings to go with Rev pulleys. V-groove pulleys come with the V-groove bearing shields from GoBuilder to prevent the string coming off of the groove. Small pulley bearings from Rev are similar to GoBuilder V-groove pulleys, but are slightly smaller in size. Belt pulleys from Actobotics has teeth-like bumps on the pulleys. Instead of using strings, this pulley drives belts in order to pull the slides. How slides are used in FTC. Linear slides are usually used to extend your part of the robot to grab, intake, or place a game element. For example, in Skystone season, most teams use extendable slides to stack stones on top of each other to score points. Therefore, instead of using just one set of slides, they are usually stacked together in order to have a longer reach. You can also use slides to extend forward in order to grab or reach game elements. A good example is the Robo-Ruckus season. In order to reach the elements in the crater without having to actually go in and out, we use multiple sets of linear slides to extend the intake system into the crater. Since the slides had to be extended horizontally, we mounted them flat on the crossbeam supported by the chassis frame. These are example slides from Robo-Ruckus season. During the relic recovery season, we had to reach outside of the field to score the yellow figure called a relic. Because the relic wasn't heavy and we needed more compact slides with long extension, we decided to use one series of slides rather than two parallel sections. How to stack and mount slides. GoBuilder system, Actobotic systems, and Rev systems all have different screws and attachments to use. GoBuilder system uses 4 screws and GoBuilder brackets. Actobotic system uses 632 screws and Actobotics brackets. Rev Ultra Slides and Linear Motion Kit uses M3 screws and work well with Rev attachments. Mizumi Slides also uses M3 screws. These screws are small enough to fit inside the sliders without getting in the way of movement. To secure the screws in the slides, we put a small M3 nut on the other side of the screw to keep it in place. These small M3 nuts hold the Mizumi slides together. Otherwise, the nut rubs against the middle section of the 3-step slide. When mounting the slides to each other, you have to be careful to have them facing the correct way. If you are to mount two slides together, it must be extending the same direction to the one you are mounting to. How stringing works. One of the crucial parts of linear slides is stringing. It basically means putting strings on pulleys that are placed correctly throughout the moving sections in order for the slide to extend and retract. The picture to the right indicates the small green circles as pulleys. Red lines as strings. And the big green circle as a spool. Spool is attached to a motor, so when the motor rotates, the string on the spool is pulled and the linear slide extends. Continuous versus cascade slide. Continuous slide uses one set of string, while the cascade slide uses many set of strings. Continuous sliders, when extended, go up after each other, but cascade sliders, when extended, go up simultaneously. Cascade sliders are faster when extended, but take more torque, while continuous sliders take a little bit more time to extend, but can take less torque. String or belt. String. The pros of string are that they are easy to build. The con is that string may snap, get jammed, or come off from pulleys. String can be a little high maintenance since you have to run a lot of checks before to have them make sure they have no issues. Belts. The pros of belts are that they are very strong and they don't snap. But the cons are that belt tension is critical, but it's hard to maintain. Belts can skip, but the solution is to add idler pulleys to the drive pulley. They also take more space than strings. Other issues that we experienced. Issue number one is that Loctite tracks CAD modules such as pulley covers or custom-made brackets. The acetone in Loctite weakens the ABS and causes a lot of cracking in our brackets. The solution to this is to use PLA instead of ABS to make 3D printed parts. Issue number two, screws get stuck inside the slider. The solution is to use magnet or a screwdriver to pull them out, or just shake the slider a bunch. That easily fixes our problems a lot. Issue number three is finding a balance between tightening the screws too loose or over tightening them. The solution is, well, like I said, find a balance. As you work with sliders a lot, you'll eventually be able to find the balance between tightening the screws too loose and over tightening them. Thank you for listening, and if you have any questions, please email ToborTech@gmail.com.